But what I want to talk about today is a line of best fit. So in this section, we're talking about data, we're talking about graphing data, and we're talking about describing sort of the relationship between two variables. So in this case, we are just taking a random x variable, and the x is represented by the horizontal axis here, as usual. And the y variable, so the x is independent, the y is the dependent, and the y variable is on here. Now, we don't have a real-life description for this example. It's not mass and speed or something. It's not height and time or anything like that. It's just x and y. But what I want to get at is, what is the line of best fit? Now, the line of best fit, as a definition here, this is from your textbook, 6.3, it's a straight line that best approximates the trend in a scatter plot. So a scatter plot is when we actually graph the points that are represented by the ordered pairs here. So you've copied this down into your notebook. So what we're going to do is we're going to make a scatter plot, first of all. So making a scatter plot, we understand that this right here, this 1 and the 1 here, that's a point that's going to be on our graph, right? And it's the x value of 1, so we go over 1. And then we go y value of 1, up 1, and we place a point right there. Okay, everybody remember how to do this? From elementary school probably when we first started doing this? Okay? So if we plot the rest of these points, so again, it's always the x value first, 2, 4. Okay, so each of these points on my graph is 2. So 2, 4, it's going to be up over here. And so why don't you just take a moment to plot all these points, and then we'll take a look at how we do a line of best fit. All right, so you've got your scatter plot made by putting all of these points on the graph, okay? And this is what your scatter plot should look something like. If you have graph paper, you're going to be a little better off than me, because I don't have graph paper. I'm just estimating here my horizontal and vertical lines. However, it should look something like this. Shh. Pay attention, please. Now, the line of best fit, okay? So what is a line of best fit? It is a straight line that best approximates the trend. So we can kind of see that as x increases, what happens to y, generally? As x increases, y increases as well. So we have a bit of a trend where x increases, y increases. Now, the straight line would approximate what this data and what it does. So what is a line of best fit? Let's copy down some of these things here. So what is a line of best fit and what is it not? Okay, lobs, yeah, lobs, lines of best fit. Okay, what do they do not have to do? They do not have to go through all of the points. Okay? They don't have to go through all the points. Consequently, it's not a connect the dots activity. Okay? Now, when we're talking about a line of best fit, that is a straight line. Now, there could be a curve of best fit, which is a smooth curve that might pass through most, if not all, the points. But in a line, oftentimes, the line does not go through all the points. The line of best fit does not have to go through the origin. It might go through 0, 0, but it does not have to do that. So many times students start at 0, 0, and they try and make a straight line from there. That's not necessarily true. And they don't have to go from the first point to the last point either. Okay? That's very important. You do not just simply connect the first point and the last point. Now, it may turn out that the first point and the last point may be on the line, but it is not necessary. You understand? So, what you want to do with your ruler, now that you've got your points all set, and it actually works better with a clear ruler or a clear, protractor or whatever you have with you there, what you want to do is you want to place a line, and use pencil in case you have to erase and do this over again, but you want to place a line that kind of goes through as many points as possible, but also a line that is right in between as many points as possible at the same time. So you want to have an equal number of points equally spaced above and below the line. Does that make sense? So let me give you some examples of maybe what wouldn't be a good line of best fit. Let's see, where are we? Let's do this line here. I'm not sure what color this is going to turn out. Okay. So, the line is black. That helps out a lot. Okay. Let's change those pen properties. Let's make it green. And let's make it a little thinner. Okay, so this, not a good line of best fit. Not. Why? Because we have 2 points that are below the line, and we have 3 that are far, far above the line. So, you know what I mean? Like, that's not a very good representation. So what we want to do, maybe, is, let's just try and manipulate this line a little bit. So what we might want to do is move this line up a little bit. Now, is this a good line of best fit? We're getting close, but we have all the points underneath the line. That's not a good line of best fit. So what if we just move this down a little bit so that we have more points that are equally spaced above and below the line? So look at that one. That one's not too bad, actually. That one's not too bad. Now, if you did something like that, probably be okay. Could you manipulate that just a little bit? And again, it's a little tough for me here just to micro adjust this, but maybe that's a good one too. Okay. So do you guys kind of understand what's going on here? Okay, so that would be a pretty decent line of best fit there. We have an equal number approximately above and below the line, equally spaced. So if we get into a technical calculation, and your graphing calculator is going to help you create a line of best fit. And what it's going to do is it's going to do something like this. It's going to take all the points, and it's going to create a line in here, a set of points, where the square of the distances all are equal above and below. So it doesn't matter whether it's positive or negative, but the spaces above and below the line from each point will will balance out. Okay? So that's a line of best fit. This is what a line of best fit does not have to do. All right? And again, that's how you make a line of best fit. Now, what we can do with that line of best fit is do 2 things, really. We can interpolate, that is, use interpolation, and extrapolate, or use extrapolation. So you're going to need to jot these down into your notebook, please, so you understand what these are. So just take a moment to copy this. Interpolation, the root word of that is inter. So this is the process where we estimate a value within the domain of the set of data, inside the first and last points. And extrapolation is the process to estimate a value that's outside of the domain. So we extrapolate. It's extra. It's outside. We make a guess as to something that's outside of what we're actually measured. So let me show you how that works. Okay, this is where we'll end this little section here, interpolation, extrapolation. But let's say we wanted to know from this graph, and using our line of best fit, we wanted to know what the value was for the number 5. So if x equals 5 right here, this is called interpolating, okay, because it's inside the numbers that we have listed here. So where's 5? 5 is right here. So what we do is we would go from 5 straight up until it touches the graph, and then we would estimate what this value actually is. So from our line of best fit, it appears that 5 is attached with 2, 4, 6. Yes, there's another number attached with 6. That's okay. If we were being really specific, it might be 5.8 or something. Okay, but you see how we use the line of best fit to do that. So extrapolation would be something like, well, let's find out what 18 is, or 17. Let's go 17. So 17 is outside of the data. And notice the line of best fit starts and ends at the first and last point. It doesn't actually stretch beyond, technically. Okay? But 17, we can use this line of best fit, and I'll use this green marker here, to draw a dotted line, and we could extend this line to project what the values might be if the trend continues. Okay? So that's called extrapolation. So 17 is outside of our measured data, and it would be somewhere around right here. What value is that? That appears to be maybe 21. Okay? So 21 would go with 17 according to our line of best fit. Okay? So that's how you make a line of best fit. These are some guidelines you want to look at to creating one. And also, what is interpolation and what is extrapolation? Okay? Do you have any questions about that?